So let's look at those again. Give you another chance to look at them, compare them. So notice how all those zeros, leading zeros, are being dropped. All right, well, what else can we do here? What else can we do? Well, another option we have is to take successive fields of 0 and combine them together as a double colon that we see right here. So in this case, we have successive fields of 0. All of these, and all of these. What if we combine them together? Essentially remove all the zeros, squish it all together, and then this double colon here comes together with this double colon. Boom. And that's what we see right here as our example. So now we have 2001 DB8 100F 1 double colon ACD. So by dropping successive fields of zeros, we can make it even smaller. So let's look at that. It's called the double colon substitution. So there we go. So just by doing double colon substitution, look how those addresses shrink down for us. It's a big difference, a big difference. Look at example number 4 at the bottom. Just goes to double colon because it was all zeros. Now it's just double colon. Look at option number 3. It just ends up being double colon 0001. Or example number 2 there, FF01 double colon 0001. So let's look at the originals. There you go. So dropping or combining those successive fields of zeros into a double colon. Now, what about combining both rules together? Watch this. Watch this. If we combine both rules together, we can truncate our addresses extensively. Look at 3 and 4. That's what I want you to focus on here, 3 and 4. So I'm going to go back here to just a double colon substitution. That's what it looks like with just double colon substitution, 3 and 4. Let's go over here. That's what it looks like with just dropping leading zeros. But let's do both rules in this case. When you do both rules, you'll see here. There you go. You'll see here that we get double colon for 4, and we get double colon 1 for 3. And then when you go to 2, it's FF01 double colon 1. So both rules combined, you can really shrink it down. Now, what's wrong with example number 1? Look what it says. It says incorrect. Incorrect. The top one is correct, but the one underneath it's incorrect. What's wrong with the bottom one? What's wrong with the bottom one? In example number 1 right here. What's wrong with the bottom one that says incorrect? Let me tell you what's wrong with it if you're not sure. You notice how there's a double colon substitution twice there? See that? Double colon substitution is twice. What does it say here? It says, you can only do the substitution. You can only do the double colon substitution once in any given address. Once. Why? I've done it twice here. If you do it twice, the address cannot be converted from... The address can't be determined if you do double colon substitution twice by the device. And the reason why is because when you do double colon substitution, it figures out the number of bits before the double colon substitution, the number of bits after the double colon substitution, and then fills it in the double colon with a whole bunch of zeros. So that's how it figures out what the true address is. If you do double colon substitution twice, then it has to figure out how many bits are in the first double colon substitution, and then it has to figure out how many bits are in the second double colon substitution. Well, it can't do that because there's no delta there, right? There's no way to figure out, okay, if I have this many bits before, that many bits after, then it must be X number of bits in between that are 0. But if you have it twice, well, then it could be any combination. There's multiple values that could be in the first one and the second one when it comes to the double colon substitution. So you can only do it once. If you try to create an IPv6 address with 2 double colon substitutions or by dropping more zeros than you're supposed to, it's not going to work. You are going to get warnings in most operating systems that are designed to pick out the issues that you have done. But let's say you are looking at example IPv6 addresses, and you're asked to identify which are valid, which are not valid. Well, in this case, every time you see a double colon substitution done twice or 3 times, that's an invalid address. That would not work. That would not work, but on a piece of paper, that would be, oh, there's a bad address. That would not be a correct address to use. What about if you drop too many zeros? What if you dropped this 0 as well in the 10F, you put that 0? Well, that would be wrong as well. You can't drop that 0 in there, so that would be an invalid truncation of our original address. And what if you saw your address with a character of G in it? G. Well, G is not a valid hexadecimal character. It's 0 through 9 and then A, B, C, D, E, and F. G is not valid. So that would also be an invalid address. So everything that I'm referring to as being invalid, you would not be able to configure on a host. You would not be able to configure on a router. Why? Because they're programmed not to accept those values. But if you're ever looking at a sheet of paper, a document, an exam, and you have to pick out invalid IPv6 addresses, know what would cause those IPv6 addresses to be invalid. So more than one double colon substitution, dropping the wrong zeros, and last but not least, invalid characters. So 0 through 9 are valid, A, B, C, D, E, and F are valid. Everything else would be invalid.